Every year, governments invest billions of public dollars into scientific research, yet the vast majority of the resulting discoveries are systematically locked behind commercial paywalls. The mechanism enabling this is copyright law. Globally, copyright is a legal framework that grants the creator of an original work the exclusive right to determine how and under what conditions that work is reproduced and distributed to others. In most industries, if an employee creates something in the course of their job, copyright ownership defaults to the employer. This is known legally as a work made for hire. Academia operates on a bizarre anomaly. Researchers, employed by universities and funded by public grants, voluntarily transfer their exclusive legal rights to private corporate publishing houses. This chart shows the resulting economic feedback loop. It begins here at the top, with public funds paying for the foundational research and the researcher's time. The critical failure point occurs at this central padlock. By transferring copyright, the author hands the publisher a legal monopoly over the specific findings. Because the publisher now owns the exclusive rights, the public and the university libraries must pay subscription fees to access the exact research they originally financed. By surrendering the legal rights to their own work, creators construct a structurally unsustainable system that actively prices them and the public out of their own intellectual output. Granting private monopolies exclusive control over mandatory academic knowledge triggers severe macroeconomic distortion. This graph illustrates the scale of that distortion. Looking at the red line, journal subscription prices have exploded since 1986, climbing more than 300% above the rate of inflation. When you compare that steep red peak against the flat black line tracking stagnant university library budgets, the mathematical impossibility of the system becomes obvious. By the late 1990s, this divergence triggered what is known as the access blackout. Libraries were forced into mass cancellations, severing scholars from the vital literature they needed. The internet solved the technological problem of distributing knowledge decades ago. Democratizing science today is entirely a systems engineering and policy challenge. Bypassing this legacy trap requires the construction of two specific mechanisms: an active policy engine to force compliance and a structured data commons to house the results. We cannot rely on market corrections to fix a broken monopoly. Achieving open access requires dismantling the copyright choke point through proactive institutional force. This diagram maps the complete end-to-end architecture required to reroute global research outputs away from paywalls and toward public accessibility. Digital infrastructure, like repositories and servers, is passive. It requires an external forcing function to operate. We define ignition as strict funder and institutional mandates that legally require researchers to deposit their public-funded findings into open repositories. This timeline tracks the historical acceleration of these mandates. It starts at the bottom left with the Wellcome Trust in 2005, the first major funder to pioneer open access, and tracks upward to 2013, when the U.S. government directed federal agencies to adopt similar standards. This chart shows how top-level national data sharing policies cascade downward. Moving to the second tier, we see specific actions. The Indian Council of Agricultural Research, for example, mandates open repositories across all its institutes, creating a central harvester for local knowledge. Strict policy mandates are the proven mechanism to override traditional copyright transfers and guarantee that academic output reaches the public. Once a mandate forces research to be open, the output must travel through one of two primary transmission pathways. This matrix categorizes the two routes. On the left, the green OA route relies on authors self-archiving in institutional repositories at virtually zero cost. On the right, the gold OA route provides immediate access, but shifts the cost burden to researchers via article processing charges. Legacy publishers recognized the threat of the green route and engineered a critical vulnerability into the gold route to maintain their profit margins. This graphic illustrates the hybrid trap. Subscription journals charge an exorbitant fee to unlock a specific article. As noted below, this creates double dipping. Universities pay massive subscription fees to read the journal, while their faculties simultaneously pay thousands to publish in it. Relying solely on publisher-defined gold open access pathways without building robust institutional green infrastructure risks bankrupting research budgets entirely. Simply making a PDF free to read, known as gratis open access, is insufficient. True scientific acceleration requires Libra open access, meaning the underlying data is legally free to reuse, adapt, and remix. This graphic illustrates the current state of global research data. On the left, information exists in isolated, unstandardized silos. The right side presents the necessary solution, shifting to standardized, linked formats that allow diverse sets of open material to reliably intermix. This diagram outlines how raw data must be processed. At the top, unstructured data enters representation and discovery filters. Moving down to identification and access, data is tagged with persistent IDs. Finally, the bottom filter stamps open licenses, outputting polished, linked open data. Data only becomes a useful scientific tool when it meets the rigorous FARO standard. It must be findable, accessible, interoperable, reusable, and open. The ultimate destination for this polished data is a sustained data commons, a global network that aggregates hardware, applications, and verified datasets into a single cohesive infrastructure. This illustration represents the architecture of that data commons. To prevent the system from collapsing into an unusable data swamp, it requires strict structural pillars. Looking at the two leftmost pillars, the system relies on permanent digital IDs explicitly linked to discoverable metadata, ensuring stable access control. The middle pillars highlight the technical requirements of API-based access and seamless data portability. These ensure researchers can move their workflows across diverse environments without being locked into specific computing environments. Operating this infrastructure introduces real friction. Cleaning and hosting massive datasets is highly labor-intensive, and aggregating localized data carries inherent risks of exposing sensitive information. However, these maintenance costs are dwarfed by the socioeconomic accelerators. A properly managed commons combats data rot, drives environmental transparency, and ensures taxpayers receive the full value of the research they fund. Building a managed, interoperable commons is the defense against the anti-commons effect, a scenario where fragmented, paywalled ownership permanently stifles global innovation. This architectural theory is grounded in historical reality. The implementation of open data systems has already enabled specific, large-scale scientific breakthroughs. This graphic details the 1996 Bermuda Principles, which governed the Human Genome Project. The organizers mandated that all genomic sequence information had to be released into the public domain immediately upon discovery. By committing to open, interoperable formats, rather than locking sequences in proprietary silos, the project established the foundational infrastructure for all modern biotechnology. While different fields face unique hurdles, the core mechanics used in genomics, standardized metadata, and open repository software provide a mature blueprint for other data-intensive domains. The final missing component is not technological. It is the administrative courage required to draft and enforce strict open access policies. Institutional leaders hold the lever to the mandate engine. By using it, they ensure that the outputs of human intellect bypass commercial monopolies and remain a permanent, interoperable public good.